Welcome to This Explainer. Today, we're unpacking something absolutely massive. We're looking at how an artificial intelligence literally just stunned the world's elite mathematicians by completely disproving a legendary 80-year-old conjecture. I mean, we are looking at a true paradigm shift here, one that really challenges the absolute limits of human reasoning and mathematical discovery. Let's get right into it. We're actually starting right at the climax today, because when world-renowned mathematicians like Noga Alan admit that a change is this dramatic, you know for sure we aren't just talking about some minor software update. He said, the impact of this is hard to overestimate. And he hit the nail on the head. The global math community was just completely blindsided by what this AI managed to pull off. And then you have W.T. Gowers. His reaction was honestly pretty terrified. He said if AI could come up with a proof like that, then maybe it would be all over for mathematicians very soon. You see, he first misheard the news and thought the AI had proven the conjecture true, which would have required this massive, unprecedented conceptual leap. He was definitely relieved to hear it had only found a counterexample, but his reaction really highlights a terrifying realization. The machines are literally knocking on the door of elite human intuition. Okay, so let's dive into the riddle that sparked this whole shebang. It's a super famous puzzle in combinatorial geometry, and honestly, it's one of the easiest to visualize. Imagine you just have a bunch of dots scattered on a flat piece of paper. The fundamental question is simply, how often can the exact same distance occur among a specific number of those points? This is formally known as the Erdős unit distance problem. It was proposed by the legendary Erdős way back in 1946. This seemingly simple little problem asks about the maximum number of unit distances, which basically just means pairs of points separated by exactly a distance of 1. Think of it like taking a strict 1-inch ruler and seeing how many times you can connect specific dots within a set of points without exceeding known mathematical bounds. Now, Erdős didn't just casually ask the question. He really staked his reputation on the answer. He was so incredibly confident in his assumed upper bound for this, he believed the answer was roughly n to the power of 1, that he eventually offered a $500 prize for its proof or disproof. Now, adjusted for the ego of top-tier mathematicians, that $500 bounty really cemented this problem's status as a major global target. Think about the timeline here, because it really puts things into perspective. We're talking about decades of human stagnation. Sure, in 1984, researchers like Spencer, Schmaridi, and Trotter found a major upper bound, but for 80 years, the core conjecture just sat there, completely untouched. Everyone basically assumed Erdős was right. The problem was considered a closed loop. Well, that is until an autonomous machine reasoning system completely shattered that illusion in 2026. The mathematical world was shaken to its absolute core when an internal open AI model actually generated a counterexample. It proved Erdős's long-standing conjecture unequivocally false. And you have to understand, this wasn't an AI just predicting the next word in a sentence, right? This was a rigorous, structurally sound mathematical disproof of a conjecture that almost every human expert believed to be true. And just to prove this wasn't some crazy isolated fluke, Anthropic's Claude Mythos system independently solved it shortly after. They used an agentic harness, which you can kind of think of as a virtual boardroom where different AI instances brainstorm, divide the workload, and summarize paths. And Claude Mythos found what was described as a cute, simple proof. This is a huge deal. It signals a serious overhang in AI-driven math capabilities, with multiple systems now independently breaching the frontier. But hey, here is the silver lining for human intellect. We aren't entirely out of the loop just yet. Human mathematician Will Sawin actually had to step in to translate the AI's raw, kind of alien logic. He took the AI's complex, inexplicit exponent and really sharpened it up. Using the AI's foundation, he successfully proved that there are more than n to the power of 1.014 unit distances. Basically, he cleaned up the AI's raw discovery into a precise, explicit mathematical bound. So that brings us to the million-dollar, or well, I guess the $500 question, how exactly did a machine do what the smartest humans couldn't do for 8 decades? Well, it all comes down to how the AI manipulated algebraic number fields in a way that human experts had just systematically ignored. The AI took this massive conceptual leap. Imagine humans were trying to solve a maze drawn on a flat piece of paper. Well, the AI basically looked at that paper, folded it into this complex 3D origami shape,
and found a shortcut through a dimension that humans found way too terrifying to even explore manually. First, it started with a 2D grid of Gaussian integers. Then it generalized that original grid logic into complex number fields, and finally scaled it all the way up to highly complex, infinite class field towers.
Let's break that heavy number theory down a bit. See, human brains naturally organize data by fixing the environment and changing the variables. It's just how we make sense of things, right? Well, the AI did the exact inverse. It fixed the variables and warped the environment itself into infinite, towering dimensions. It approached the architecture of the math entirely backward to how a human is traditionally taught.
This really highlights the stark difference between the two approaches. On one side, you have our human bias. We blindly assumed Erdős was right, and we spent decades trying to prove his upper bound. But on the other side, the AI. Completely unburdened by mathematical folklore, it didn't assume a thing. It just systematically hunted for a counterexample, completely unbiased.
Mathematician Arl Shanker noted something absolutely fascinating about the AI's internal chain of thought. It was purposefully venturing into mathematical waters that human experts had dismissed as a total waste of time. It possesses this superhuman patience. Humans get tired. We get discouraged when a theory doesn't pan out immediately, but the AI doesn't. It has this incredible willingness to explore these long-shot constructions without ever feeling fatigue.
Thomas Bloom echoed this perfectly. Because we humans were anchored to a non-optimal belief, we were all siloed in very specific approaches. We entirely missed the counterexample hiding in plain sight, simply because almost no one was seriously trying to disprove the conjecture. Our collective assumptions literally became our blind spot. It really makes you wonder, doesn't it? In your own industry, how many unsolvable problems are just waiting for someone to stop trying to prove the old rules right and simply try to prove them wrong? In the wake of this disproof, top mathematicians are having a profound moment of professional introspection. When a machine beats the absolute brightest minds at their own game on a famous problem, it forces a complete reevaluation of the entire profession. It's a real game changer. Experts like Daniel Litt realized pretty quickly that this wasn't just some party trick based on language mimicry. This was a profound, autonomous mathematical discovery. The AI actually taught humans brand new structural properties about algebraic number theory and discrete geometry. This isn't just a sign of future potential. The actual math it produced is genuinely exciting and totally novel in itself. I absolutely love this framing from Thomas Bloom. He talks about AI helping us explore the cathedral of mathematics. We are entering an era where AI is no longer just a glorified calculator. It's becoming a true mathematical explorer. It's capable of taking the theoretical machinery we humans have built and using it to connect deeply disconnected fields of thought. It's bridging islands of knowledge that we previously thought had absolutely nothing to do with each other. This milestone is proof that by combining superhuman patience with an encyclopedic grasp of algebraic number theory, AI can solve the exact problems that currently bottleneck human attention. Let's face it, we humans are limited by time, funding, and career incentives. But AI? It can just trawl through entire problem lists and pursue dead ends until they suddenly open up into unprecedented breakthroughs. It's officially transitioning from an assistant to an independent discoverer. Which leaves us with this final, incredibly provocative thought. If an AI can tear down an 80-year-old pillar of mathematics just by looking past our human biases, what else is out there? I mean, if it can do this for geometry today, what is it going to do for physics, medicine, or climate science tomorrow? As our collaboration with machines evolves, what other absolute limits of human knowledge are about to be entirely rewritten? Thanks so much for joining me on this explainer, and keep questioning the limits of what's possible.